So in this video we're going to talk about vectors. A vector is a quantity that has both magnitude and direction. So a lot of the time you'll see them drawn as an arrow. So the length of the arrow is the magnitude, right? The direction is just the direction that the arrow is pointing. And this makes it actually pretty easy to deal with vectors. Now the problem is that things don't always travel in the same line all the time, in the same direction, or with the same magnitude. So let's say that something travels along this first arrow, and then it travels along this second arrow. So maybe we should give them some letters. Let's give them A and B. So if something travels along A and then travels B, what we need to look at is what would be the total travel. So what would be the displacement? So what we need to do is add these vectors. So to add the vectors, we need to go tail to tip. So what that means is that we just draw them again. Okay, so that's A. And all we need to do is make sure that the tip of one of the arrows is touching the tail of another one of the arrows. Okay, so this is one way to draw it. Another way to draw it would just be this. We could draw our arrow A, and then we could draw our arrow B, right? It's still tail to tip, and it's still right. It doesn't matter which way you draw it, because our total displacement is you start at the tail and you go to the tip of the next one. That would be our total displacement, so that would be A plus B. And it would be the same for this way, A plus B. And as you can notice, they're the same length of line, and they're in the same direction. So it doesn't matter which way we do it. All we need to do is draw two vectors tail to tip, and then draw the resultant vector. Let's try another example. So this could be example 1. Let's try example 2. So what if we had a travel straight north and then another travel straight north? How would we draw that? Well, all you need to do is draw them tail to tip. So it would be like that. So our total displacement would be the length of both of the vectors added together. Now what about, let's try another example here. We could go down like that and then up like this. So what we could do is draw them tail to tip. So we're going to draw it like this. So there's the tip, and then we're going to have the tail of the other one. So our total displacement then is going to be this. That's going to be our total displacement. So we draw our two initial vectors tail to tip. Okay, it's very important. Don't draw them tail to tail because that would be wrong. Don't draw them tip to tip because that would be wrong. You just make sure that the tip of one is touching the tail of the other one, and then our resultant vector is going to be from the first tail to the last tip. And that's how you do it. So let's do another example. Let's do a word problem. So some hikers walk 14 kilometers due south from their camp. So let's see here. We can draw our arrow. It's going to be 14 kilometers. So that's due south, right? It's just down. They walk 2 kilometers due east. Okay, so 2 kilometers due east. A, what is the total distance walked by the hikers? So A, the total distance, all we have to do is add these up. So 14 plus 2, so 16. So 14 plus 2 is equal to 16 kilometers. So B, what is the actual displacement the hikers are from their camp? So they aren't 16 kilometers away from their camp as the crow flies. They're actually this distance away from their camp. So to do that, all we did was add the vectors, and we just need to find this other side. So we need to find x. So how are we going to do that? How are we going to find x? Well, it might look familiar to you. This question might look familiar to you because this is a 90-degree angle. So we can just use Pythagorean's theorem. So we're going to use a squared plus b squared is equal to c squared. And we're going to find this side. So this side is actually the hypotenuse. So it's c. So we're going to say 14 squared plus 2 squared is equal to x squared. because 14 and 2 are A and B. So then we're going to square them. So 14 squared is 196 plus 4 is equal to x squared. So then 200 is equal to x squared. We need to get rid of the squared, so we're going to take the square root of both sides. So x is going to equal the square root of 200, which is just 14.1 kilometers. So the total displacement that the hikers have gone from their camp, right, if their camp was here, if they walk down and then to the right, their actual total displacement is just going to be this extra side of the triangle.